Okay, this is lesson video for Unit 6, Lesson 7, and we are graphing radical functions. And in particular, we are graphing square root functions and cube root functions. Now, this should feel somewhat familiar. I mean, we are graphing, we've done tons of graphing, and we're answering all the same questions we always do when we graph, but this time it's just a different type of equation we're graphing. But it's going to follow a lot of the same transformation rules we always have. And again, answering questions we see pop up all the time. So it shouldn't be too hard. So we start off with our parent function of a square root function. Now, parent function is the most original or basic way that you can write a function. So that would start off as f of x equals, and because it's a square root function, we need to make a square root, and we would just add an x to that. The square root of x is the most basic way that we can show this. Any extra number or sign is a transformation to this original function. Now, if we graph that, okay, you type it into your graphing calculator or to Desmos, okay, we would get something very interesting on our graphing calculator. And I'm going to maybe kind of show it here on the side. If you look at your table of values, and maybe like you'll see -3, -2, -1, 0, 1, 2, 3, 4, and so on, you would see that it says error, okay, for these first few, for y, which is different. We haven't really had that happen before. And at 0, then it would say 0. 1, there's going to be a decimal. 2, a decimal. Not 1. Sorry, 1 is 1. 3 would be a decimal. And then when x is 4, y would be 2. Okay, the next time we would have a whole number point would be when x is 9, y is 3, and so on. Now, why does that happen? Remember, we're plugging these x's in, and we square root them. We cannot take the square root of -3 or -2 or -1 and so on. These make imaginary numbers, so they do not work. They're not part of our domain, and we cannot graph them. But once we start having 0, right, the square root of 0 does work. It's 0. The square root of 1 is 1. 2 and 3 yield decimals because they are not perfect squares. The square root of 4 is 2. And then the square root of 9 is 3, and so on. So we're only able to get perfect squares that come out with whole number points to plot. So you'll just notice as we do these, the radicand can never equal a negative number when it's computed. Okay, we can plug negative numbers in if there's a number being added to x, subtracted to x underneath, but it can't compute to a negative because we can't take the square root of negatives. So let's plot the points that we got for this. We start at 0, 0. We're at 1, 1, and then at 4 and 2, and 9 and 3. So it's different. It continues to the right forever, but it doesn't continue to the left forever. It has what we called an end point. And I like that someone said in class today, it should be called a start point, which I agree with because we go left to right. But they've named it an end point because it ends right here. The domain is always our x values. Okay, where do we have x values for this graph? We go left to right. So we start having x's at 0, and then we go to the right forever, which would be infinity for x. So we're going to say that it is 0 with a bracket because 0 is included, to infinity with a parenthesis because we can never reach infinity. Then our range is our lowest to our highest. So we go to our endpoint again. Our lowest is 0 for y, and it's moving up slowly, but it is moving up forever, which is infinity for y. So our range is also 0 with a bracket to infinity for y, parenthesis. So this is the parent function. Again, we can stretch this, shrink it, shift it left, right, up, or down, but this is what all of our square root functions originate to. So now we have the parent function of a cube root function. So this is f of x equals the cube root of x. This is the most basic way that we can show the cube root function, and again, all other cube root functions originate from this graph. If you type this into your graphing calculator or Desmos, okay, we're going to get a line that continues onwards for both directions. We can't take the square roots of negatives, but we can take the cube root of negatives. So if you're looking at your table of values, okay, because this is a 10 by 10 grid, I'm going to go as far back as, let's say, -8. When x is -8, the cube root of -8 is actually -2. Doesn't make it an imaginary number. So we can graph that. When x is -8, y is -2. And then we don't have another point we can plot until, okay, we would say -1. The cube root of -1 is -1. So it's right here. And then 0, 0. And then 1, 1. And then we have +8 and +2. So it looks something like this when it's all connected. Okay, we have not an end point on this one, we have what's called a turning point. You'll notice that when you graph these, we'll always end up with 3 points, I'm going to go over them again, in a row that are clustered together, and our turning point is in the center of them. Okay, and that turning point for this one is 0, 0, which makes sense. You usually have something that passes through the origin, right? Our domain, okay, is left to right. We are going to the left forever, which is -infinity, to the right forever, which is +infinity. So we could write the domain like that, or we could say that it is all real numbers. They mean the same thing. Now our range is our lowest to the highest. While on the left side, it's moving down very slowly, but if given enough time, we could go forever. It will go down forever, which is -infinity as our lowest. On the right side, it's going up slowly, but it is going up. So it'll reach or head to +infinity over time. So it's -infinity to +infinity, which is also all real numbers. Now, all graphs can be transformed in some way. Okay, so we've done this with other types of graphs. The transformation rules are the same. Our equation that we are referencing, or the formatting, okay, for radical terms is this. F of x is equal to a, and then the nth root of x minus h plus k. Now, a, h, and k represent numbers that could be in these positions, and a, h, and k are what's always used to show like horizontal shift, vertical shift, stretching and shrinking, reflections, and so forth. So let's start with h. Now notice the h, okay, I'm going to do a different color here. H right here, it's always with the x. Now we've done this with absolute value and parabolas. Okay, h is with the x. The x-axis moves side to side, left to right, which is horizontal movement. And horizontal actually starts with an h. So h is the horizontal shift. Now remember, I used to call them sneaky exes. Hey, do you have an ex-boyfriend or girlfriend? Maybe they're their ex because they were being so sneaky. The exes always do the opposite of what the sign says. So remember, sneaky exes. If it says plus, that doesn't mean right, it means left. It does the opposite. If it says minus, it goes right. That many spaces for whatever number is in there. So sneaky exes. The k value is always being added or subtracted after the radical, okay? So it's not the number underneath the radical. It's after it at the right side, and it represents vertical, or your up and down shift. Now, y's aren't sneaky, okay? Things are up or down. That's pretty straightforward. They can't be sneaky about it. So plus means up, minus means down. Okay, and then your end point or turning point is kind of like finding like the vertex. It's always your h and k value. The number that's with x and the number that's the up and down shift make your end point if it's a square root function, the turning point if it's a cube root function. Now our a value. A is the number or the sign that's in front of the radical sign. So it's in the very, very front. If it is negative, okay, it means the function is reflected across the x-axis. We're always reflecting across the x-axis in this class. Okay, and negatives have always meant the arrows in down or that we are reflected. So that's nothing new. That should feel familiar as well. Now, absolute value of a, okay, is what we're referencing now. The negative already had its job. The negative means it's going down. So then we look at the number portion that's in front of the radical. If that number is bigger than 1, okay, if you're getting bigger, stretching actually means to make something bigger. So if the number is bigger than 1, we're going to make it a vertical stretch. Okay, if your number is between 0 and 1, which means it's a smaller than 1, that literally means to shrink something, right? If it's getting smaller, so it's a vertical shrink. Another word that you could also use would be compression. Okay, so these are all of our transformation rules. They really haven't changed. We always use A, H, and K, and they always do the same things. Okay, on these next 4 examples, we have to identify the transformations. So remember, your parent function is just like where the x was at. We have here the square root of x minus 7 plus 2. The parent function is the square root of x. So anything extra besides that represents a transformation. So minus 7 is a transformation, and so is plus 2. Minus 7 is a sneaky x. It's with the x underneath the radical. So sneaky x is not going left 7. Usually minus means left. It's going right 7. It's doing the opposite because it's a sneaky x. Plus 2 is on the outside. It's a y. Y's aren't sneaky, so it's just going up 2. Okay, what are you up to? We're doing math. Yay! Okay, number 2, we have 4 times the cube root of x. So this part right here is the parent function. That makes 4 some type of transformation and minus 1. 4 is in the A position. It represents a stretch or a shrink. 4 is bigger than 1. Getting bigger means we stretched it. So it's a vertical stretch. And you usually should say of what number? So we'd say of 4. And minus 1, it's not under the radical, it's after the radical. So it means down 1 space. We don't have any other numbers to talk about, so those are all the transformations. Okay, number 3. Okay, we have the cube root of x, that's the original part. So we have this negative sign and this plus 3 that are added to the parent function. Okay, a negative out front always means the same thing. It's a reflection across the x-axis. Okay, we haven't reflected across the y-axis yet. Plus 3 is inside with the x. Now, even though it says plus 3, it's a sneaky x. It means it's going left 3 spaces. And then number 4, 1/2 times the square root of x minus 2 minus 6. So 1/2 is extra, minus 2, and minus 6. We have 3 transformations. The 1/2 is in the A position. A is a stretch or a shrink. 1/2 is smaller than 1, so it's a vertical shrink of 1/2. Okay, that's our first one. Now the minus 2, it's with the x, sneaky x, so it's going to do the opposite. It's going right 2. Minus 6 is the y. Y's aren't sneaky, so it's going down 6. Okay, now on these next couple examples, they're telling us the transformations and what type of parent function, and we have to write the function equation. And it's actually pretty easy. So start with what type of parent function you have. We have the square root parent function. So I would start off by saying this is f of x equals the square root of x. That's the parent function of a radical function. Now we add the transformation numbers to this. So the first thing it says, it was reflected across the x-axis. Having a negative out front is what makes a reflection, so we'll put a negative out front. Then it says it was shifted 7 units left. Well, I know x's are sneaky. If it's left or right, it has to be with the x, but left actually means plus 7. 1 unit down, y's aren't sneaky. It goes after. 1 unit down means minus 1. And it says write the equation. We have done that. So we just started with the parent function and we added all those numbers and signs to it based off those transformations. Number 6, it says a cube root function has a turning point located at -2, 3 and write its equation. So again, I'm going to start with the parent function. F of x equals the cube root of x. That's the parent function. So cube root x is what we start with. It has a turning point located at -2, 3. Now, this is written as a coordinate, so it's told us the transformations in a different way. But I know that a coordinate is an x value and a y value. Or we could say they are the h and the k. Okay, but we have our x transformation of -2, the y shift of 3. So I know that if a value comes out as -2 for x, x's are sneaky. It goes back in with the opposite, plus 2, with the x. The y shift is our k value, and that means plus 3. There were no other transformations, so this is the finished equation. All right, now on to graphing some radical functions, and you will see these on your homework and as well as your test. So to start off, we're going to graph the square root of x plus 5. Now you should know that there's not anything with the x, there's no left or right shift. Plus 5 means this has been just shifted up 5 units, and you'll notice that when you type it into your graphing calculator. It's a line that does not continue in both directions, it just continues to the right forever. Your first point after all the errors is the first point you plot on the graph, and that would be at 0, 5, according to your table of values. 1, 2, 3, 4, 5, right here. And then it would say 1 and 6. And the next point you could plot would be 4 and 7. Okay. And it continues out to the right. So let's answer our domain. Again, your domain is your x's. Okay. Where do you start having x's? It will be the first x after all the errors on your table of values, and that would be 0. Notice it continues on the right forever, and the right forever is infinity for x. So the domain is 0, positive infinity. Your range is always your y's. So it's your lowest to your highest, and it does need to be in that order. So here my lowest point is at 5, and then it goes up forever, which is infinity. So we would say 5 with a bracket, because it actually equals 5, to positive infinity with a parenthesis. We have an end point, not a turning point, and that end point again was our first point at 0, 5. Okay, end behavior. Now end behavior, you're really telling about what's happening on the two sides of your graph, the right side for x and the left side for x. So we usually answer the right side first. Now this is our right side. On the right side for x, this line is continuing to the right forever and ever. So that means x is headed towards infinity. And as x approaches infinity or goes to the right forever, this is going up more and more and more for y, which is f of x. So it's ending at positive infinity for y. That's pretty straightforward. But then we have our left side. Well, negative infinity would be over here for x, but we're not headed that way forever. We actually have an end point, which means we stop here on the left. And where are we stopping? So think as we travel this way to the left, the furthest left we can get for x is 0. And as we get closer and closer to 0 for x, y stops at 5. So you'll notice that it's always the end point for the left side of our end behavior. It'll always match up the x and the y value. Now, increasing and decreasing intervals, for which x values do we have positive or negative slope? And for these cube roots and square root functions, it'll only be one of these, not both. So let me show you what I mean. So the slope from left to right is always headed up, which is increasing. Where are we increasing from? Well, we start at 0 for x and we head to infinity because it's always increasing. And we actually do 0 with a bracket to infinity and close it because 0, we usually don't use brackets for increasing, decreasing intervals because they're usually a switching point, but we're not switching. It actually starts at 0 and it equals 0 for that increasing value and heads to the right forever. It is never going downwards, so we do not have a decreasing value. Okay, number 9, we're skipping 8. We have 3 times the square root of x plus 1. So you type that into Desmos or your graphing calculator. Okay, we see that we have lots of errors until we get to -1. And, sorry, move that. -1 and 0. That's the first point we can plot right here. -1, 0. The next point we can plot, I said that backwards, is 0, 3. And then 3, 6. 1, 2, 3. And then 8 and 9. Okay, so notice we did have this 3, which meant there was a vertical stretch. You can totally tell that this goes up a lot faster. It's stretched more than that other one was. Okay, and that's because of that 3 in front of our radical. That's what a stretch looks like. Okay, now let's see how our domain and our range has changed. Our domain, where do we start having x values? We start at -1, and then it goes to the right forever, which is infinity. So we would say the domain starts at -1 with a bracket, comma, to infinity for x, parenthesis. Range is your lowest to your highest. So our lowest value is 0, and then it's going up forever, which is infinity for y. So say bracket, comma, with 0, comma, infinity, parenthesis. Now our end behavior, very similar to the last one. Okay, on the right side, we are going right forever. So we're saying x is actually approaching infinity. And as we go to the right, this is ending up to positive infinity again. On the left side, we do not go left forever. The furthest left we go is right here, this dot, which is -1 for x and 0 for y. Okay, as we go to the left, we approach that dot or end point. Now, what do we have here? Increasing or decreasing? We always read it from left to right. Okay, so it is going upwards, which is increasing interval, so no decreasing. And it's for which x values are we always increasing? It's -1 to infinity. You'll notice that for these square root functions, it's always the same as our domain because it's the same x values. Pretty cool. All right, number 10. This is going to be f of x is equal to negative square root of x minus 2 plus 3. Okay, so we type that in. And you could notice this also from just looking at the equation. We do have a reflection, and our endpoint should be at 2, 3. And according to your table of values, that is also correct. The first point we have after the errors is at 2, 3. The next one we could plot is at 3, 2. And then 4, 5, 6, and 1. And then like 11, 0, which is right here. So because it's reflected, this one is headed, kind of missed that, down into the right, like this. All right, looks a little goofy, but that is correct. Okay, it doesn't change how we find our domain. Domain is the x values we cover from left to right. So we start having x's at +2. We still go to the right forever, so that's infinity. So we say it's 2, comma, infinity with a parenthesis. The range is your lowest to your highest. So this one is a little bit different. Because it's headed down, the lowest we'll get over time is -infinity. The highest we get is at the end point this time, which is +3. So lowest goes first always. That's -infinity, comma, 3 with the bracket. So it's reversed because it was reflected. Okay, it's an end point again. The end point was at 2, comma, 3. Now end behavior will be a little different as well. We are working on the right side first. And as we go to the right, which is infinity, so x is approaching infinity, meaning moving to the right forever, this side is still, it's going down, which is -infinity. Now, what's the left side? Okay, as x approaches the left side, the leftest we can get is +2 for x, and as we approach +2 for x, y ends at 3. Okay, so it's still that end point. And then decreasing or increasing values. From left to right, this is always headed downward. So this time we do not have an increasing interval. We are decreasing for the x values 2 to the right forever, which is infinity, not -infinity. So 2 with a bracket, comma, infinity, parenthesis. Again, decreasing meant going down. Right forever. It's the x values. It's +infinity. Okay, now on number 11, we are doing cube root functions. Okay, so we type this in. And we're going to go, and I'm going to check this out. I know that our table goes from -10 to +10 for x, so I'm looking around -10, and I can see that it does go to -11 and 0, which I can eyeball. That's about right here. And then we have -4, +1, so 1, 2, 3, 4, up 1. And then we have -3, +2, -2, +3, and +5, 1, 2, 3, 4, 5, and up 1, 2, 3, 4. Okay, and then just kind of make it match your table and match the picture of your graph. Okay, now our domain and range are different on this one than our radical functions because we have arrows extending in both directions forever. So on the right side, okay, we're going right forever, which is infinity. We're going left forever, which is -infinity for x. So we're going from -infinity to +infinity, which we call all real numbers. Okay, the range, on the right side, we're going up forever. On the left side, we're going down forever. So we're going from -infinity to +infinity again, which is also all real numbers. All cubic functions have a domain and range of all real numbers. On this one, we have a turning point. Again, recognize that we have these 3 dots in a row. My turning point is in the middle of those 3 dots, and that was at -3, 2. Okay, you could also identify it from our shifts. Remember, sneaky x's, that comes out as -3. The y stays the same. So there's more than one way to recognize it. We do have normal end behavior. Okay, it's different than the square root functions because we do have those arrows extending in both directions. So on our right side, we would say on the right, we are going, x is headed right forever, which is infinity, and we already said that it was headed up as we move to the right. So f of x also approaches infinity. On the left side, okay, we're going left forever, which is -infinity, and on this left side, we're going down, so y is approaching -infinity. Now, increasing or decreasing intervals. Now, notice from left to right, okay, look, I'm going up faster, still going up. We're going up all the time. We're going up in different like rates, basically, but we're always heading up. So there's no decreasing interval. And for which x values are we headed up? From negative infinity to positive infinity. And that's how we would write it. Negative infinity, comma, positive infinity. Okay, and to finish this lesson off, we'll do number 12. We have a negative 2 cube root of x. So you should notice that the negative, this should be a reflected cube root function, and it's also stretched by a factor of 2. So when we type this in, we get a point at negative 8, positive 4 for x. So we're right here, and that negative 1, positive 2, 0, 0, 1, negative 2, and 8, negative 4. Okay, so like so. All right, so the domain, we're still going right forever, which is infinity, left forever, which is negative infinity for x, so it's still all real numbers. The range, the lowest we're going is negative infinity. The highest we are going is positive infinity, so the range is still also all real numbers. We have a turning point. Okay, our turning point, notice even though it's done, like it's more stretched out, we still have these 3 dots in a row. The turning point is the one in the middle, which is 0, 0. Okay, end behavior. On the right side, okay, this is x approaching infinity. Y is headed down, we said, to negative infinity. On the left side, okay, that's negative infinity for x. That's where we're headed, left forever. We're ending up at positive infinity. Now, what about our intervals here? Okay, we're headed down from left to right, down some more, still down. We are always headed down, never up, and we are decreasing forever from left to right. So that would be from negative infinity to positive infinity. All right, that's it. Good luck with your lesson. It was a worksheet, pretty much like these notes, so good luck.